In this video, we are still on complex numbers, but we're going to look at complex numbers that are written in a polar form. Polar form, it's a different notation of working with your complex numbers. Polar form are complex that are written in this format. These formats are just for curiosity. The angle that is between the x-axis, positive x-axis, or should I say positive real x-axis, or should I say real axis, is called an argument. And the distance to the point is called the modulus, or the absolute value. It's modulus. It's all modulus. Other people call it absolute. Okay, so how do you get the radius, or should I say the modulus? Let me say you're given a complex number a plus b I that we've been working with, complex number z. Okay, so you know that on the plane you have your imaginary plane and you have your real plane here. So this means that you go on the real part, you go a to the positive direction, you go a, and I call this one a, and on the imaginary part, I've made a mistake there. The real part is this one where a is supposed to be, x is supposed to be. So you go a, after going a, you then take the imaginary part, you go b part. So this is supposed to be b, this is supposed to be a. Then we can have our r. R is just there. Okay, so how do we get modulus or r? As you can see, this is just a simple right angle triangle. You can use our old friend Pythagoras, and Pythagoras said a square of the hypotenuse is equals to the square of the other sum of the squares of the other sides, of which this is just what you see, right? Then we can have our modulus equals to a squared plus b squared all under a root. This is your modulus. It can also be written by I plus A plus I, and inside this absolute value notation. So this is the same as the modulus, or other people call it the absolute value of the complex number. Okay, the absolute value is more of like a distance. That's why we use this notation for absolute values. So I have just written here for simplicity. Notation that I need to pass by, when they writing argument, they must say argument of complex number z. This is how you write it for notation purpose. And for your absolute value, you write it like this. It's z under this absolute notation. Since now we know a, we can find b, and we know r, the radius. Yes, the radius is still the correct term, or the absolute value of this complex number. We can now find b, right? B can be expressed as r. It's b, the theta that you're talking about argument is here, so it's going to be opposite sine theta, right? But b is on the imaginary plane, so it comes with I. Let's look at a. A is going to be r, because it's adjacent, is going to be cos theta. It's on the real part, nothing, we don't put an I. And then now we can write z, the complex number, as we can write it as r sine theta. Or let me start with we normally start with the real parts, then the unreal parts. R cos theta plus sine theta I, then we had r here. And if you notice here, we have a common factor of r. We can factor it out, right? we can just have r here, and what is going to remain here? We're going to have cos theta plus sine theta, and then sine comes with I. Then this is another notation of writing what? Writing our complex numbers in a polar form, because we normally write our complex numbers as a plus bi. We can also write them like this, and you need to be able to interchange between these two notations. This is called rectangular because this is like you go this way and this way, and that is more of a rectangular notation. And the polar one, you given a distance and the angle, you just measure the angle and go straight, and then you find the point or your destination. So both of these notations are interchangeable. We're going to do example interchanging them in the following videos. Let me say I give you a function like, not a function, a complex number, like 5 minus 3. Let me do 2 plus I. That is a complex number g. Okay, so we can write it in a complex and in a polar form. How do we do that? We can first find the modulus. What is the modulus? The modulus is just the radius. We have a here, we have a here, we have b here, so we can solve it out. So it's going to be the modulus of this complex number is going to be equal to 5 squared plus 3 squared, all under a root, and you're going to get 25 plus 9, all under a root, and then your answer is going to be root 34. And now we know our r is equal to root 34. We can now try also to find the argument of this complex number, and the argument is always tan opposite over adjacent. What is our b? Our b is 3, it's going to be 3 all over 5. And then we get our argument. And note that I have minus 1 here, showing that I want to find an angle, and I can get the angle of 30.96 degrees. This is our argument. Then we can now write this complex number in this notation. So it's going to be g is equal to our r. Our r we just got to be 34, and we have cos theta. Our argument was 30.96, and then we have plus I sine the argument, same argument, 30.96, and then we close the big bracket. So we can now change between the rectangular notation to polar form of complex numbers. Then I'm going to do another video on examples where I work out more example on this if you find it hard to understand. And please comment if you need any help in any of these topics, and don't forget to like, subscribe, put the bell button if you want to see more of our stuff every time we upload.